There's three main methods for solving systems. We're getting to our final one, which is solving by elimination. We did graphing, we did substitution, now we're doing elimination. What does the word eliminate mean? Take out, cancel out, get rid of. So our goal is going to be to get rid of or cancel out one of the variables. Now, elimination method is best used when you have your functions in this format. It's called standard form. You have the x's and then the y's equals some number. And you want both of your equations to be like that for elimination to work. So your goal is to basically, we're going to add the two equations. You can add two equations. We're going to add them, and our goal is to get one of the variables, when I combine the like terms, to be 0. So what two numbers could I add to get 0?
Negative 2 and 2.
Negative 2 and 2. What else?
Opposites.
Any opposites. 5 and negative 5. 7 and negative 7. So that's my goal. So if I look at number 1, can I cancel out, or do any of my variables turn into 0? Yeah, which one? The x's. Notice I have a 3x and a negative 3x. And so what we're going to do is we are basically going to be adding straight down. And when I add straight down, 3x plus negative 3x is 0x. So I can eliminate those. What's negative 5y plus y?
Negative 4y.
What's negative 18 plus 6?
Negative 12.
Negative 12. And then what am I going to do to solve for y?
5 and negative 4.
Which equals 3. So that's my y. How am I going to find my x?
Plug them in.
Plug the y back in. You can plug it into either of the original equations. Sometimes I just kind of look at them and be like, oh, which one looks easier? So which one do you want?
The bottom.
The bottom. I heard that first. Negative 3x plus y. Y is 3 equals 6.
We're still putting that in.
Yeah, technically. So if I subtract 3, I get negative 3x equals 3. And then if I divide, I get x equals negative 1. So my solution is the point negative 1, 3. Try number 2. Alright, so number 2, you should have the point 0, 1. When you have just the plain numbers, you don't want to just cross them out. Okay, you got to put a 0. 9 plus negative 9 is 0. And then we solve to get x equals 0. You can take 0 divided by a number. You just get 0. And then when you plug that back in, negative 0 is just 0, and you don't need that. So 9y equals 9, so y equals 1.
Why doesn't negative 0 work?
It's just 0. 0 is neither positive nor negative. It's just like in the middle.
I reckon. It's just nothing.
Alright, let's skip down to number 5. So, are there any variables that when I add straight down, I'm going to get 0? No, because what is negative 8 plus negative 8?
Negative 16.
Negative 16. So, we have two options. You could subtract. You could say 6 minus 4, negative 8 minus negative 8. But we could also think of it as multiplying something. So if I want to turn one of these negative 8s into a positive, what could I multiply by?
1.
Negative 1. So you can actually take one of your equations and multiply everything in that equation by something. In this case, we're going to do -1. Right? And that works. Why does that work? Well, let me show you an example. If I have 3x plus 1 equals 7, and I solve that, that would be 3x equals 6, x equals 2. Right? What if I multiplied everything in that equation by 2? 6x plus 2 equals 14. Would I still get x equals 2 as my answer? I would have 6x equals 12, so x equals 2. Yep. You get the same answer. So that works. So we are allowed to multiply everything in an equation by something, and it basically remains the same, as long as you multiply everything by that same number. Right. So, correct. So -1 times 6x is -6x plus 8y equals 10. And then I am going to choose to leave my second one the same. 4x minus 8y equals -28. Now that I did that, can something cancel?
Yeah.
The y's, right? -6x plus 4x is -2x. 10 plus -28 is -18. So x equals 9. Good. Which equation do you like better, the top or bottom?
Bottom.
Okay. 4x, whoop, my x is 9, so 4 times 9 minus 8y equals -28. That's 36 minus 8y equals -28. What's -28 minus -36? -64.
When did it become -36?
Well, you got to subtract it from both sides. We're solving for y, so we would subtract 36. So -28 minus 36.
You just said -36.
Okay. -28. Well, it's positive here, but then we subtract it from both sides.
Yeah.
Yeah. So -28 minus 36 is -64. If I might have said it backwards. And so y equals what?
8.
8. So what is my solution?
9, 8.
9, 8. If you get an answer and you're like, yeah, that doesn't look like, maybe those numbers are bigger than what you've been getting. What you could do is you could go back to your original equation and plug in a 9 for x and an 8 for y and see if you get -10. 6 times 9 minus 8 times 8. Yep, check the other one. 4 times 9 minus 8 times 8 is -28. That also means that if you have a multiple choice question and you forget how to solve it, you could just test out your answers to see which one works. Okay. But for now, you have to show your work. So, number 6. Try number 6. Alright, -2, -2. Did anybody not get that but don't know how or don't know what mistake you made? Anybody? You have to be really careful with your positives and negatives. That'll throw you way off. Alright, let's go to the back. Number 7. So are there any of these equations that I could multiply by -1 to cancel out? No. But I could multiply by 2. It doesn't have to be just -1. You can multiply by any number. In fact, you could multiply by a fraction if you wanted to. If you wanted to multiply by 2/3, that seems to be more work. But you could multiply by a fraction. You could, if you multiply by 1/2, that's the same as dividing by 2. So technically, you could divide by a number as well. But if I just saw this, my instinct would be to multiply the top one by 2. So -14x minus 14y equals 14. And then the bottom one we left the same. And so I can cancel out my x's. What's -14 plus 10?
-4.
-4y equals 14 plus 32. And then if I divide both sides by -4, I get y equals -8. So if I plug this back in, let's just go with the top one. I would have -7x plus 56 equals 7. What's 7 minus 56? And so both sides by -7 gives me x equals 7. So my solution is the point 7, -8. All right, try number 8. Go to number 10. Alright, so number 10, you're probably going to want to multiply the top one by 2. And you'll notice both of your variables cancel, which essentially leaves you with just 0 on that side. Equals 14. Does 0 equal 14? No. It's no solution. If these numbers over here would have also canceled or turned into 0, that would have been infinite solutions. But this one is no solution. Alright, we'll do one more. Let's do number 11. So this one, you're going to have to multiply both equations. Unless you want to go multiplying by a decimal, which is yucky. So, no, they do not have to be multiplied by the same numbers. You can multiply them by different numbers. So what's one thing that we could do?
3 and 2.
We can multiply the top one by 3. That would give us a 6x, and the bottom one by 2 would give us a -6x. You could, there's a lot of different options, but as long as you are able to cancel out one of your variables, you're good. So 3 and 2, 42. 6x plus 21y equals 42. -6x minus 20y equals -40. So your x's cancel. And then you add straight down. What's 21 plus negative 20? So just y, 1y. And 42 and negative 40?
Negative. No, positive 2.
Positive 2. So y equals 2. And then plug that back in. Solve for x. And you get the point 0.02.